Ernst, is going to talk about RightMesh and building apps on it.
Hey everybody. So I guess to start, for those of you who haven't heard about us yet, we try to come out to a lot of the events here so that everybody does know us, but I'll tell you a little bit about what RightMesh is. So I guess the first part is, who knows what a mesh network is here? Okay, so most of the room pretty informed on mesh networks. Do you know the difference between a mesh network and a mobile mesh? Does anyone want to yell it out, maybe?
Mobile mesh doesn't necessarily have a central sink. It can move from point to point to point.
Yeah, exactly. So like a lot of mesh networks that are out there have fixed infrastructure in them, almost the same thing as like cell phone towers, really, but they're just different types of wireless technology. So, for example, downtown Toronto has a mesh network. A lot of places in California, a lot of cities there have mesh networks, but they're generally hardware that sits on telephone poles and things like that. The type of mesh network that we're talking about is a mobile mesh, so it's actually the phones themselves are actually participating as the infrastructure. So our library specifically, the stuff that we provide people that are app developers is a scalable autonomous connectivity between groups of mobile devices. What that means, that sort of complicated sentence means, is that the phones will discover how to find each other, and all the protocols that we've developed basically support that, so that the developer doesn't need to know anything about a mesh network. The phones will just appear. There's events that get generated that show up when a phone joins the network, when a phone leaves the network, when data arrives at a specific phone, and we sort of abstract all the complexity of that away from the developers themselves. It can function completely without the internet involved at all, so you can have a completely local mesh that forms with no phones sharing their internet at all. But when we do have the internet involved, then you can link together groups of phones from across the world. So you could have a mesh here in Vancouver, a mesh in Bangladesh, and they could actually be linked together through the phones that are sharing their internet on it. So the way that we do this, we provide packetization, we provide routing, we provide reliable delivery, and hole punching through things like firewalls to be able to enable this type of stuff. On the left there, you can see that's sort of like the stack that we built on top of the existing stack. So some of the other mesh networks that are out there will actually require you to do things like root your phone. With our stuff, you don't need to root your phone. It's built on top of everything that exists there, so that's one of the key differences. And this is sort of a figure that shows like the phone to phone to phone communication and the infrastructure that we provide. So this is just a little bit about my background. I'm the CTO at RightMesh and the chief network scientist at Left. Before this, I've won some hackathons. I had a robotics company before this. At the robotics company, I was doing mesh networks with robots. So that was one of the robots that we had our hardware and software running on, and that could actually work in groups with other robots running the same hardware software platform as us, using similar mesh type of technology. So for a new developer getting onto our platform, the first step is going to our developer portal. That's a screenshot of it there. The link is on the bottom. All the slides here, you don't need to worry about like trying to take pictures of. I posted them on the Slack channel, so feel free to look at them later and follow through all the links and stuff. Right now, the developers, we basically require an approval process, and the only reason for that is that we can limit the amount of developers that we can support. But we are trying to really support developers from this community here first. So hackathons and things like that, we've been giving out early access to people. If you shoot us an email too, we can give you some quicker access to it. But basically, you sign up for it. It sends us an email saying that you've actually validated your account, so we know you're not a bot, and then we can approve you for access. The next step after you've been approved, you basically create a new sort of API key, and you reserve a MeshPort for your app. And what a MeshPort is sort of like a traditional networking port. It allows the multiplexing of data coming from the network to the mesh service on the phone. So if you're running, say, 5 different mesh apps, the MeshPort tells it which app to send the data to at a given time. So we globally across the mesh right now require that MeshPorts are unique to particular apps, so that someone can't create an app and listen on the same MeshPort as you and try to intercept all your traffic. So basically, as you generate your key, you create your MeshPort and tie that to the app that you're developing. So this sort of shows a figure of a mesh where we might have a whole bunch of different apps running on the mesh. All in the figure on the left, all of the phones there are actually running different apps, but you could have a phone running multiple apps at the same time, and that's more what the figure on the right looks like. So when we have app 1 and app 2 there, and traffic is flowing from RightMesh to RightMesh, that's sort of the service layer or the library. That's where we're using real network ports. The mesh ports actually function between the service and the apps themselves. So the next step is within Android Studio now. So within Android Studio, they have this thing called the build.gradle file. In Android Studio, it uses Gradle files sort of like a makefile system if you're used to C programming or something like that. This is where you basically set up the repositories and add our library into it. So the first step there might be a little tricky to see for the people farther in the back, but all you're basically doing is adding our URL for the repository. Normally on Android development, they have Maven repositories or JSender or those types of things. We're just running sort of our own version of one of those that ties in user authentication. And that sort of allows us to control right now who can get the library. In the longer run, the entire library will be open source and we'll just publish it right on Maven and there won't be that requirement anymore. The bottom line there adds our plugin to Android Studio. The plugin's job is basically to get the license file and the MeshPort information and package it into your app. So the first part of that was basically just adding the plugin. The next step of this is a few things that are specific to the library itself. So most of this other stuff here is all stuff that you'd see in a standard Android Studio project. I'm just highlighting where you need to make modifications for our stuff. So you add in, again, your credentials at the top. Those would come from the developer portal itself when you create your account. The only other sort of tricky thing, you have to enable multi-dex on a lot of the older phones. The reason for that is because our library links to a lot of other libraries, and when you do that in Android Studio, it creates a whole bunch of symbols on the like functions and things like that that you can look up. And if it gets too big, then it has to split it up into multiple dex pieces. So multi-dex is a library that can sort of hook those multiple pieces together so that all the functions can be found. The bottom part adds the library as a dependency. And at that point, you're basically ready to start building the app. So before we get into like all the code it takes to make the app, I guess the one thing I should talk a little bit about is the RightMesh events. So there's a few key events that happen when you're using a mesh app. It's all modeled on a sort of RxJava, ReactiveX type of programming model. The first one is when the library initializes. So there's a whole bunch of stuff that has to happen when you start up RightMesh as a user. So things like giving permission to access Wi-Fi scans, Bluetooth scans, giving storage permission so that we can create the mesh identity on the phone. If the user doesn't do some critical ones there, then the initialization could completely fail. And so it'll report to the developer whether or not they gave some of the permissions at that point. Or if something else goes completely wrong, it may fail for various reasons and report that to you. Other than that, there's events that get generated when a device joins the network. The only other important events, I guess, are data received and encryption events. So I'll go over some code for all those types of events. So the sort of first step is initializing the library. On the left there, you basically see what you would basically get if you started a new the blank activity. The first change that you have to do there is this mesh state listener. So you have to implement the mesh state listener, which basically says you're going to implement this function right here, the mesh state change function. That function is what fires after the library has either initialized or failed to initialize. If it's successful, this will be filled in with the mesh ID of the device, and the state will be set to success. If something goes wrong, that UID is null, and there'll be some kind of error state reported back to you. So the way that we sort of recommend to create the library and initialize it right now is in the onCreate for the activity itself. So basically what happens is when the phone app starts up, the onCreate function gets called pretty much right away. That would initialize our library right away, and things would proceed from there. So So this is an example of a mesh state change function. It has sort of two cases here. It's really the bare minimum. On the first case, on the if statement, it's the success case. If it is successful in initializing, this is where we do some of the sort of key functions that enable everything else. So the first one that you see here is this bind function. That is where you tie the MeshPort that you reserved in our developer portal to the app itself. So at that point, you might say bind to port 9000 or something there. So if your developer portal key has 9000 reserved in it, it'll be packaged into your app. The library will check if you actually have permission to reserve that port. If you do, then it will start listening on that mesh port. That function itself can also fail, and it returns errors in a similar event-driven way. I just don't have it set up here for that. The next two lines are basically registering another couple of event handlers. So the first event handler here is the peer change function. So that thing is implemented by the developer and fires every time a new peer joins, leaves, or gets updated in the network. And the other important one is the data receive function. So that thing fires anytime data arrives for the specific peer in the network. So this requires that both of those functions are actually implemented somewhere farther down the code. I'll show a couple examples of that as well. This one right here is the peer handling function. So this function, one of the parameters that it gets passed is this RightMesh event. And depending on the type of event, there's different information that gets passed there. So the peer discovery event has a state that tells you whether the peer is joining the network, leaving the network, or just updating its connectivity. And then the other thing that's important is this event peer UID, and that's how you know the mesh ID of all the peers that are joining or leaving the network. And then you can do things in your UI based on that sort of information. So you could update like a list saying that a new peer is joined, add a new peer to that list in the UI, and do things like add it to like a chat or something like that. The data sending and receiving functions work sort of similarly. So this is the sending function. The key thing here is the send data reliable function. So this takes the mesh ID that you want to send to, and this would do a unicast send from the source to the destination. So the source would be the device that you're running this on. The destination is the receiver mesh ID that you probably would have got from that discovery function, and you tell it the port that you want to send it to. So if that receiver actually isn't listening on that mesh port, it'll get dropped by the mesh service. Otherwise, it will figure out how to split that data up into packets. It'll figure out the routing, and as far as the other side is concerned, an event will just get generated when all the data arrives. So this is the opposite side of that. So this is the receiving side here. And on this side, basically, you get the opposite of that. So you get the peer ID that sent you the data, and then the data itself is stored in this event.data side. So the last important part is just the cleanup of the library. So this will get called when your activity is stopping, so when the user is closing the app down. And this step is sort of important because it properly cleans up on that whole initialization process we did at the start. If this part isn't done right now, it can really mess some things up for our library. So, I mean, obviously this is something in the future that we need to be able to handle, but right now, if this isn't done by the developer, then it makes it hard for the library to start again the next time. Some stuff for people for debugging. If you recall at the start of the talk when I was showing how to include the library, we had the library without this -dev on it. If you use that version of it, it by default has all of our debug output turned off. But sometimes turning that on to be able to trace like what's going on with the library is useful. So you just add this -dev, and then most of our output is done through logcat. So you just do a drop down of this selector here on logcat, and that actually lets you change which process you're watching. So when you start a RightMesh app up, there'll be the app process, and then the mesh process will be running in the background. So you can actually switch to that one and see the output specifically from the mesh itself. And that will tell you a lot of useful things. It will show you when devices are being discovered, when data is trying to be sent. So if something's going wrong, you can figure out if it's your code, if it's our library, and then if it is our library, then you can basically copy some of this stuff and send it to us and help us debug it. Some of the stuff in terms of connectivity, there's sort of some advanced mode stuff that you can do. So At the time that we're going to be doing like a real public launch, everything will be completely autonomous. Right now, I would classify it as sort of partially autonomous. You still have to do some setting of things in terms of like turning on Wi-Fi, Wi-Fi Direct, or Bluetooth for particular phones. So if you want to force the phones into certain modes, you can do that through these settings things, and there's more documentation on our website about how to do this. So that's also possible. And if you do run into a bug and we're sort of emailing you back and forth, we'll probably request you to set certain phones into these modes to help us fix it. So a couple of the gotchas and known issues. One of the biggest ones is that RightMesh manipulates the Wi-Fi settings on the phone to basically force it into connecting to certain networks at a given point in time. So if, for example, the cleanup isn't done correctly, then that settings on the phone get a little bit screwed up. So you may end up in the case where you've got a bunch of networks in your Wi-Fi settings on the Android, and if you run a later app that's a RightMesh app, it won't be able to make changes to those settings anymore because it's tied to which app started up RightMesh. So if that happens, then we basically need the user right now to manually go through and remove all the old networks that are saved. That's probably one of our biggest known bugs, and we're working on fixing that. But if you start using the library now, you'll obviously find that problem. Like I said, there's still some manual aspects to connecting. The autonomous stuff is in progress, and hopefully will be done in the next few weeks. And right now, when you manually change some stuff, sometimes it requires the library to be restarted. So those are probably some of the biggest issues. The next little bit is basically just a couple of demo videos of some of the apps we made. So all the stuff I've been talking about so far has been Android apps, but we can also run stuff on like IoT devices like this one. So this is something running on an Arduino, and then it's talking through Bluetooth to a phone, and then the phones are all reporting to each other that there's like a smoke alarm type of thing or a heat sensor. We could run that as well on something like a Raspberry Pi with our library running natively in Java on the Pi, or any other device that can run Java. The code is almost exactly the same, so this stuff on the right is actually a Java version of our stuff rather than an Android version. And this example here is showing app super peers. So those things are basically running on Java on a device that may be on like an Amazon server or something like that. They may be attached to databases or things like that. And so this example here is showing as our devices are connecting to each other, we're seeing like a visualization. The visualization is running on Amazon, and the phones are sending all the information to an app super peer to show how they're connected to each other. This is what our documentation stuff looks like. It's basically Java docs, and then we have the Slate documentation system that shows some examples on there. This is some early testing we did in Rigolette, which is a community in northern Labrador. The middle figure shows how far into town we covered with it, and the figure on the left shows near our office. Both of those examples are about 1,000 feet, and I think 6 to 7 hops on most of them. The video on the right is showing us doing some in-field testing with those links that are in the middle figure. So there's a guy like way down the road, and it's hopping through several phones, and you can't really see the messages very well on the phone. Yep.
So is that Bluetooth, or is that through the cellular network, or is that?
It's that one is all using Wi-Fi hops. So there's I think five Wi-Fi hops there. It could use a combination of Wi-Fi and Bluetooth in that case, but there's no cell phone towers in that town at all, which is why we're doing testing there.
What sort of throughput are you getting? What sort of bandwidth?
Right now, the top we've been getting is about 1 megabit per second.
Bidirectionally or unidirectionally?
Unidirectionally right now. We think we can get a lot faster out of it, but really we've been focusing on just making the autonomous connectivity first, and then our whole layered system with the reliable communication. So we've actually implemented our own protocol that's similar to TCP or like LTP or something like that. So the early stages of that were very slow. Like at first we were doing like on the order of like kilobytes per second. So it's gotten a lot faster.
Now the last question is what sort of security do you have? How do you keep somebody from snooping it?
Yeah, so we can do end-to-end encryption on it if you exchange keys with the other person. But if, for example, say you're the person on this end and you want to talk to the person on this end, and you have to exchange the keys through the network, then obviously there can be a man in the middle. If we have multiple paths, we can split it up and send it across multiple paths. But like the best way would be if you exchange the key with the person like when you're close to them using some kind of near field technology or a barcode or something like that, then as long as they go farther into the mesh, then it's okay. So with that stuff, we give the developer some idea on how secure the key exchange was. If they have exchanged it through the mesh, we consider that a fairly insecure key exchange. If they've exchanged it locally, we consider that a secure exchange. And then we also tell them if it's like a completely open channel as well. But that part sort of comes down to whether the developer implements that or not. The app on the left there basically shows some of our routing stuff. So a lot of the other mesh stuff on phones will do really naive broadcasting, and all the phones will basically get the message and just hopelessly pass it on to the other ones. When this one shows up with a few more phones on it, you'll see that it only sends the message to the phones along the path rather than to all the phones. And this one on the right here is just showing our Hello Mesh app with a whole bunch of phones on it. I won't play all of them. You guys can check those out later on YouTube if you want. So that's about it. Any questions?
So wouldn't this like kill your battery?
Yeah, we get that question a lot. But if you look at, for example, everybody in this room, if your phones were all connected to the cell phone network, using something like 4G is something like 20 times more energy than using Wi-Fi. And then if you use Bluetooth, it's something like 10 times less energy than Wi-Fi. So, I mean, if you're forwarding all the time and you're sending a lot of stuff, then there's probably some point where, yeah, you're going to kill your battery faster. But there's some trade-off where, like, if we can offload a whole bunch of these people onto only a few people's phones connected directly to the cell phone tower, then we're probably using far less energy. Especially if we can select the people who are the closest to the cell phone tower to be the ones that are forwarding on behalf of us, and we strategically select them, then we can probably on the long run use a lot less.
Could you select nodes that are plugged in preferentially?
Yeah, that would be ideal. If we picked those ones, that'd be the best.
We'll just choose one that says charging, right? In a charging state, then you know it's plugged in.
Yep. Yeah. So the one part that I didn't really get into a lot on this talk is like, why would anyone forward data, or why would anyone share their data into this at all? And that part is really covered by the token aspect of our stuff. I didn't get into the details, but basically we're allowing people to set the price of what they want to sell their data for, and other people will have to purchase the data in it. And all the people sort of in between that part would also get some of the reward as well.
So does this mean we can use our cell phones in the airplanes now?
In my opinion, there's not really any reason why we can't use it. I think it's more like while we're taking off, like they don't want you to be distracted in case they need to get out fast.
The main reason is because once you're up in the air and you're using your cell phone, the information is sent through multiple towers, and that's why it creates
the handoff would be too fast for it to work. But like, so the phones are on the plane are a bit of a, like I don't think you'll be able to share it to the cell phone towers. But like if you have a case where like one guy on the plane or one woman on the plane buys the plane's stuff, then you could like share it to everybody else for free. But you can do that now if you set up like a Wi-Fi direct hotspot or Bluetooth pairing with somebody else. You can be cheap. Like I do that all the time.
Fair enough.
Can you provide a bit of details of your network stack?
Sorry?
Of your networking stack? A bit more details?
Yeah, that's something we're working on for the version 3 or version 4 now, I think, of the tech white paper. It's been requested quite a bit. Originally, we weren't providing details on that because we were filing some patents on it. So we have 2 patents in various stages on that stuff, and have basically made it our strategy that we're only using it defensively. So we're filing them so that people can't come and tell us you can't do this because we've got a patent on it. So now that those have gone along, we're basically going to put out all the details of it. Basically how the devices discover each other, how the routing mechanisms work, how the data transmission works. The eventual goal is the entire thing will be open source, and then we can work with other people on like an interop standard.
Did you think of onion route? People do fun.
Onion routing like Tor and things like that. Yeah, I think that's like a natural fit. So like in our system, because we don't use IP, so I didn't mention it, but we don't use IP addresses anymore because all of our stuff is based on hotspots, and an IP address in one hotspot doesn't really make sense in another hotspot. So we abstracted away to our mesh IDs instead, and that maps various IP addresses, MAC addresses, and everything to a mesh ID. So when you're internal in our mesh, and you're not at the edge touching like the cell phone network, you're basically anonymous in the mesh. But the edges aren't. So like at the edges, that's like a perfect fit for something like Orchid or Tor or something like that to be running, and then the entire mesh would be completely anonymous.
How resilient is it to outages? If you have one of your nodes drops out, can it reroute? Can it figure out how to reroute?
Yeah, it does its best right now. I would say that's definitely an area for improvement, but it can recover from some of that.
And how long does it take to recover, right? So.
Yeah, it depends. I mean, that's all the stuff related to performance is still early days. So we're working on the tools right now to be able to measure all that type of stuff. But yeah, that's a huge concern. So the strategy for that is first let's work on like almost a static case, and then like a very low mobility case, and then like high mobility, sort of like the same strategy as the cell phone networks.
Could you possibly put a routable service on one of the phones in the network, like a web server or something like that? Is that possible?
Yep, that'd be possible. Yeah, you could do something.
Could route into it.
Yep. The one thing I think that would also be super interesting is if we tied into some of the services that are doing almost like a naming service on decentralized systems. So something like I think Blockstack is doing something like that. There's a few of them that are doing that type of thing, and basically make a replacement for DNS that hooks into this.
Is there a token involved with this?
Yes, it's called Mesh.
What's the utility?
It's basically exchanging the value of forwarding traffic. So it sets a price for people to sell their data into the network, and then for people to forward along it. Yeah. So within probably the next 2 to 3 weeks, we'll have a prototype of that working on the testnet, aiming for the Koban testnet. And it's going to be using something similar to like a microarray in the channel.
So the port is actually up to the developer to decide. If the port is already used due to, like, say for instance, I'm running, before I run Mesh, I'm running, I don't know, let's say for instance Tor, which is connected to a certain port, and I'm connected to that port, then would it be able to alternate between like different ports and figure out which one isn't used and then select one randomly and then adjust accordingly?
So are you talking about like the MeshPort or our real data ports?
No, the real data ports.
Yes, it can kind of do some of that stuff. There may be some issues if you ran into that type of thing though. Right now, I don't think it would be able to. I mean, it would know if it was our traffic or not, and then it would just discard stuff that wasn't our traffic at this point. But in terms of like trying to do anything useful with the other traffic, probably nothing. Like, so the one thing to distinguish right now is in the stage we're at now, it doesn't support general purpose internet traffic. So you could do something like from 10 hops into the mesh, go to like Google's website and do that. It's really meant for like if you have a mesh here and you want to talk to a mesh in another place, it can do that right now. The longer term goal is that we will support general purpose stuff, but that requires a whole bunch of stuff. We've already got it planned out in our roadmap, all the details of what we need to do for that, but it's a little bit complicated.
All right, sounds good.
Thank you.